Question number 2. Question 2. 9 raised to power 2k plus 1 equal 81 raised to power k plus 2 all over 3 raised to power k. Since the lowest among all the bases is 3, we are going to write both 9 and 81 in index form to base 3. 9 is the same as 3 raised to power 2. 3 raised to power 2 is 9, so we bracket 2k plus 1 equal 81 is the same as 3 raised to power 4 bracket k plus 2. Instead of writing this, I put this, okay, which is they are the same, division, 3 raised to power k. Let us open the bracket. We are going to have 3 raised to power 2 times 2k is 4k, and 2 times 1 is plus 2 equal 3 raised to power 4 times k, 4k, and 4 times 2 plus 8 divided by 3 raised to power k. Remember what I said in one of the questions, you cannot compare the bases yet because here we are still having more than one base. So what you do, you first of all ensure the base on the right hand side is 1. So by looking at the base, okay, the bases are equal, okay, so we are going to pick 1. So let's bring the left hand side the way it is. 4k plus 2 equal the base is 3, the base is 3, we pick 1, and since the sign is division, we are going to apply the division rule. Okay, so and it is going to be, we are going to subtract the powers, so that gives us 4k plus 8 minus k. Okay, so if we simplify this, the left hand side is going to give us the same 3 raised to power 4k plus 2 equal 3 raised to power. Remember, you cannot add this and this because they are not like terms, but 4k minus k are like terms, and if we subtract k from 4k, we are going to have 3k. 3k plus what now? Plus 8. Now by comparison, the bases are equal, we equate the powers, so that gives us 4k plus 2 equal 3k plus 8. If we collect like terms, we subtract 3k from both sides, we are going to have 4k minus 3k, okay, and also we subtract 2 from both sides, we are going to have 8 minus 2. So at the end of the day, 4k minus 3k will give us k. Is that taken? No need of writing 1 invisible. There's a 1 there, so no need of showing it. 8 minus 2 will give us 6. So k equal what? 6. We can check. If we put 6 here, we are going to have 2 times 6, 12. 12 plus 1, 13. Okay, 3 raised to power 9 raised to power 13. Okay, and we can reduce this to 3 raised to power 2 for 9 bracket 13, and that gives us 3 raised to power 26. That is the left hand side. Then if we check this, if you put 6 here, 6 plus 2 is 8, so we have 81 raised to power 8 divided by 3 raised to power 6 because k is 6. Okay, the right hand side now. So the base here, we are going to reduce it to base 3, that gives us 3 raised to power 4 into bracket 8 divided by 3 raised to power 6. 3 raised to power 4 times 8 is 32 divided by 3 raised to power 6. We apply the division rule. We have 3 raised to power 32 minus 6. And if we subtract this, it's still going to give us 3 raised to power 26, which is same as this. In question number 3, okay, we have 2 raised to power 2x minus 10 times 2 raised to power x plus 16 equal 0. How are we going to solve this? First, this 2 raised to power 2x is the same as 2 raised to power x into bracket raised to power 2 minus 10 times 2 raised to power x plus 16 equal 0. We can now take we can say let 2 raised to power x equal to, let's say, y. We introduce another letter at this point. So in place of the 2 raised to power x, we are going to put y. So that gives us what? Y squared for this. Y squared minus 10 times, instead of this 2 raised to power x, we have y, because we said let 2 raised to power x be y, plus 16 equal 0. We are going to multiply this. Is that taken? So that gives us y squared minus 10y plus 16 equal 0. Now this quadratic equation again, remember we are going to multiply. We are going to multiply this to get what we call the product. So in that case, our product is equal to plus 16 y squared, this quadratic equation. Then the sum is minus 10y. We're going to look for two numbers that if we multiply will give us plus 16 y squared. We are going to look for two terms that if we multiply will give us plus 16 y squared, and if we add will give us minus 10 y squared. Now, what are the things that we can multiply to get 16 integers? If you check 4 times 4 gives 16. Okay, 8 times 2 gives 16. Is that okay? But 4 and 4 can't give 10. Ignore the signs first. Can't give 10. So you remove that. Is not what we need. But if you check 8 and 2, it has something to do with both 16 and 10. Is that clear? Now let's check the signs. Here is plus, here is minus, and have this at the back of your mind, or you remember that, or you quickly recall that minus times minus we give plus, and minus plus minus is what? Minus. Meaning the two numbers, the two integers, we are going to place minus before them. So it's going to be minus 8 and minus 2. Is that clear? Minus 8 and minus 2. Minus 8y and minus 2y. If you check, minus 8y minus 2y, when you multiply this, it will give plus. When you multiply them, okay, it will give plus 16y squared minus 8y plus minus 2y. When you simplify it, it's going to give minus 10y. So remember I said the first will remain the same. Why the two terms will replace the middle term here, the sum, which is minus 8y minus 2y. If you like, you write minus 2y minus 8y. We are going to get the same result at the end of the day. Then plus 16 will also remain, the constant will also remain the same, all equal 0. Now this and this, what is common? You can say clearly y is common. Bracket open. Y squared divided by y will give us y. Minus 8y divided by y will give us minus 8. Bracket close. Here what is common? After writing the sign minus, assuming here is plus, you write plus. So what is common? 2 is common. Bracket. 2y divided by 2 will give us y. Plus 16 divided by minus 2 will give us minus 8 equal 0. If you open the bracket with minus 2, you are still going to get minus 2y plus 16. Now, look at this and this. What is common? Y minus 8. Now open the bracket again. All these divided by this will remain y. All these divided by this will remain minus 2. All equal 0. Again, we are going to say y minus 8 equal to 0, since is either y minus 8 is equal to 0 or y minus 2 is equal to 0, because if this is 0, 0 multiply this will give 0. If this is 0, why this is not 0, this multiplies 0 will give us 0. So you split it into 2. So at this point, y equal to 8 or y equal to 2. Are we going to stop there? The answer is no. You stop here, you have failed it. The reason why we can't stop there is very simple. In the question itself, look at it. The unknown variable is x. It's x we are solving for. So what do? You recall this stage. You recall this. Remember 2x, 2 raised to power x, pardon, is equal to y. That means in place of this y is used to replace 2 raised to power x. So to continue now, instead of this y, we are going to have 2 raised to power x equal 8, or instead of this y also 2 raised to power x equal 2. Writing this in index 4 will give us 2 raised to power x equal 2 raised to power 3, or 2 raised to power x equal 2 raised to power 1. By comparison, x equal 3 or x equal 1. Yes, we have gotten our x. And quickly, before we leave the question, let's check whether we are right. If you use 3, if you put 3 here, we are going to have 2 times 3, which is 6. That is 2 raised to power 6. Okay, minus 10 times 2 raised to power 3, because x is 3 plus 16. Let's simplify and see whether we are going to get 0. 2 raised to power 6 is 64, minus 2 raised to power 3 is what? Is 8, and 10 times 8 will give us 80 plus 16. 64 minus 80 will give us minus 16, minus 16 plus 16. Minus 16 plus 16 will give us 0, because since the signs are not the same, you ignore the signs, you subtract, the numbers are the same. So when you do 16 minus 16, it gives 0. And note, it's not going to be minus 0, it's not going to be plus 0. On the number line, we don't have anything like minus 0 or plus 0. It's just 0. 0 is without signs. Is that taken? We are not talking about blood group here, and even in blood group you have is even O positive, O negative, exactly. But for the fact that O, letter O and 0 looks alike, then no, we don't have minus 0 plus 0. No, nothing like that. So we say that, okay, this have given us what? 0. If we use this one to also check, here we give us 2 times 1, which is 2. So we have 2 raised to power 2 minus 10 times 2 raised to power 1 plus 16. 2 raised to power 2 is 4. 4 minus 2 raised to power 1 is 2. 10 times 2, 20 plus 16. 4 minus 20 is minus 16 plus 16. And that will give us 0. Is that taken? You can see clearly that both sides are equal, meaning we are 100% correct. Yeah, as you can see on the board, we have 2 questions, and the question says we should prove that this, that is all what we have on the left hand side, is equal to what we have on the right hand side. And in mathematics, how do we prove? How do we go about proving? This is how we do it. You are going to focus on one side of the equation, solve that side, that Lokuba sum. If you arrive the other side, if the answers are the same, you know that you have proved, you have shown that, okay, both sides are equal. So without taking much of our time, let's go to the solving. Solution. You are going to first write the question back. Okay, so we have 16 into bracket 32 raised to power m minus 2 raised to power 3m minus 2 times 4 raised to power m plus 1 all over 15 times 2 raised to power m minus 1 times 16 raised to power m minus 5 raised to power m all over square root of 5 raised to power 2m. So we are going to say from the left hand side. Okay, from the left hand side, because it's the left hand side that looks somehow cumbersome. So let's go there. This 16, we are going to write it in index form, and that gives us 2 raised to power 4 bracket 32 is the same as 2 raised to power 5 into bracket m. Okay, 2 raised to power 5 is 32 minus 2 raised to power 3m minus 2 times 4 is the same as 2 raised to power 2 bracket m plus 1 close bracket all over 15 times 2 raised to power m minus 1 times 16 is the same as 2 raised to power 4 16 into bracket power m minus 5 raised to power m. Okay, all over this square root. We are going to change everything to index form, and removing the square root become what now? 5 raised to power 2m. Okay, that is what we have under the square root. And remember, the square root implies what? Power 1 over 2. Is that okay? Power 1 over 2. So that gives us 2 raised to power 4. Let's remove the bracket. Times 2 raised to power 5m. That is 5 multiply m. Minus 2 raised to power 3m. Minus 2 times 2 raised to power 2 times m. 2m. And 2 times 1 plus 2 all over 15 times 2 raised to power m minus 1 times 2 raised to power 4m. That is 4 multiply m. The power inside multiply the power outside, 4m. Minus 5 raised to power m all over the power inside the bracket multiply the power outside. This 2 is going to cancel out these 2. So we have what? 5 raised to power m left. Is that clear? So coming to this side, we are going to have what now? The base here is 2. The base here is 2. We are going to pick, or let us leave this side like this because I'm going to factorize. Yes, I'm going to factorize. 2 raised to power 5m. I don't want to apply the law here. I'm going to factorize. Watch. Now the base here is 2. The base here is 2. I pick 2. Is that okay? What am I going to do to the power? I'm going to add, because the sign is what? Is multiplication. So that gives us 3m minus 2 plus 2m plus 2. Yes, plus 2 all over 15 times the base here is 2, the base here is 2. I'm going to pick a base and do what to the past? Add as well. So we have m minus 1 plus 4m minus 1. How do we get 1? Note, if the base are the same, is that okay? Or if what you have as the numerator is the same as what you have as the denominator, when you divide, the answer is 1. It's just like saying 10 divided by 10, 8 divided by 8, 4 divided by 4. Similarly, 5 raised to power m divided by 5 raised to power m will give us 1. Or when you apply the law of indices, 5 raised to power m divided by 5 raised to power m, the base are equal. You pick 1 among the base, which is the 5. Okay, because the sign is division, what do? You subtract the powers. And if you do that, we are going to have what? We are going to have m minus m, which will give us 0. Let's proceed. 2 raised to power 4 times 2 raised to power 5m minus 2 raised to power 3m plus 2m will give us 5m minus 2 plus 2 is 0. Is that okay? And I believe I have explained that. If the signs are not the same, you just ignore the signs and subtract the numbers. you subtract the small number from the big number. After that, you put back the sign. But in this case, the numbers are the same. So when you do 2 minus 2, you are going to get 0. And you don't need to add minus, you don't need to add plus, because here the numbers are the same. And moreover, I said it earlier that 0 is a number that don't have sign. We don't have plus 0, we don't have minus 0 as far as mathematics is concerned. So we have this left as the numerator up there, all over 15 times, again let's simplify this, that gives us 2 raised to power m minus 1 will give us what? M minus 1 we cannot subtract, so m plus 4m is 5m minus 1 minus 1. Is that clear? Now it's time for me to factorize. I remember I said I'm going to factorize the numerator. Now this and this is being separated with this minus sign. So when you look at this from here to here and you look at this, what is common? You can see clearly that 2 raised to power 5m is common. So when you bring out the 2 raised to power 5m that is common, open bracket, all this divided by this 2 raised to power 5m is going to cancel out this. We have 2 raised to power 4 left, minus 2 raised to power 5m divided by 2 raised to power 5m will give us 1, bracket close, all over 15 times 2 raised to power 5m minus 1 minus 1. Now 2 raised to power 4 in the bracket there is what? Is the same as pardon, 16. 2 raised to power 4 is 16 minus 1, okay, all over 15 times 2 raised to power 5m minus 1, okay, minus 1. Now 2 raised to power 5m, we are going to have 16 minus 1 is what? 15. Okay, just watch out. Gradually you can see the work is reducing, and finally we are going to get that 1 that they give us as the right hand side. So 15 here 1, 15 here 1, we cancel out. So what do we have left? We are having 2 raised to power 5m divided by 2 raised to power 5m minus 1 minus 1. I just have to change this line into what? Division. They mean the same thing. So apply law 2, which is the division rule, to what we have here. Is that clear? Since the base are equal, we are going to pick 1, and since the sign is division, we are going to subtract. That means minus. And note, since the power here are 2, you are going to put them in bracket. Okay, you are going to put them in bracket, minus 1. Is that taken? Minus 1. Now if this sign now open the bracket, you are going to have 2 raised to power 5m minus 5m, minus times minus is plus 1 minus 1. Is that taken? 5m minus 5m will give us 0. So what do we have left? We have 2. This and this is 0. We have 2 raised to power 1 minus 1. Is that taken? Minus 1. 2 raised to power 1 is 2 minus 1. And 2 minus 1 will give us 1, which is the same thing as the right hand side. At this point, Q, okay, we say QED, QED, quick, easily done. Is that clear? Quick, easily done. You discover that at the end of the day, we are able to get 1, which is what they put at the right hand side. You can see we solve, and we got what? We got 1 as you can see in question number 2. They ask us to show that all what we have in here, or what we have on the left hand side is equal to 27. Again, the side that looks somehow Cooper's sum is the left hand side. So we are going to say from the left hand side, from the left hand side, what do we have? We have 9, open bracket, 9 raised to power m plus 1 over 4, bracket close, root 3 multiplied by 3 raised to power n, all over, for the denominator we have 3 root not cube root. Assuming it is cube root, they will write it here, and that is where we are going to say if we are removing it, it's going to become power 1 over 3. But in this case, it is 3 multiplied by root 3 raised to power minus n, all raised to power 1 over n. So let's solve this and see what it's going to give us. First, let's change this 9 to base 3. That gives us what? Bracket open, 3 raised to power 2 for 9, and all this happen to be the power of 9, so we are going to bracket n plus 1 over 4 like this. Okay, all this serve as the power of n, so this 3 raised to power 2 is just replacing our 9. Is that okay? Times multiplication. Is that clear? We can still maintain the root first and apply law of indices here. As the power of this 3 is n, the power of this 3 is 1, so the base are equal, we pick 1. Now the sign is multiplication, we are going to add 1 plus n all over. Here we are going to write this as 3 times. We can remove the square root now. That gives us 3 raised to power minus n, okay, raised to power 1 over 2. Square root means 1 over 2. Okay, as a power, when changing it to power, it means what? 1 over 2 raised to power 1 over 2. Then we have our power outside the bracket, 1 over n. Okay, we are moving, we are making progress. Now here this power 2 is going to multiply n, is going to multiply 1 over 4, and that will give us 3 raised to power 2n, as in 2 times n is 2n. When you multiply 1 over 4 by 2, the 2 is going to cancel out this 4, and the answer will be what? 1 over 2. Okay, now times. Similarly, let us remove the square root here. Let us remove the square root. We are going to have 3 raised to power 1 plus n, bracket close, raised to power 1 over 2. Yes, any day, anytime, square root changing to power is what? 1 over 2. Now 3 times the power here, we multiply the power outside, so we are going to have what? 3 raised to power minus n all over 2. Okay, because this n minus n is the same as over 1. Is that taken? So minus n multiplied by 1 will give us minus n. 1 multiplied by 2 will give us 2. So into bracket raised to power 1 over n. Now we are moving. What do we now do? We need to remove this bracket here. So let us maintain 3 raised to power 2n plus 1 over 2 times the power inside multiply the power outside. That gives us what? 3 raised to power 1 times 1 over 2 is 1 over 2, and n times 1 over 2 will give us what? Will give us plus n over 2. Is that okay? We first of all use this to multiply this, then we use this to multiply this. That's why the power here changes to this. All over, the base are equal. Is that okay? We can pick 1. This 3 is raised to power 1. So again, we apply the law that states that if the sign is multiplication, that is law 1, we are going to add the powers. So this plus now is the one for the law. But look at the power here, is having a minus. So when you write minus n over 2, please introduce a bracket. At the end of the day, the signs will multiply. Bracket close, raised to power 1 over n. Okay. Now look at this. The base here is 3. The base here is 3. We pick a base. Okay. Always write the base big, so that you'll be able to differentiate the base from the power any day, anytime. Is that clear? So since the sign here is multiplication, we are going to add both powers. So that gives us 2n plus 1 over 2 plus 1 over 2 plus n over 2. Is that clear? All over 3 raised to power plus times minus will give us minus n over 2. You can see we are making progress. Raised to power what? 1 over n. For the numerator now, okay, for the numerator, we are going to make everything over 1 and take the LCM. the LCM is 2. I'm just trying to break it down. There are so many shortcuts I would have shown to, like, I would have introduced for me to get my answer. I want to answer, but no, students that don't like mathematics will not grab, will not understand what I'm doing. So I'm a doctor, so I need to administer drugs gradually. You know, before you know what is going on, you will become a what? A mathematician. Is that okay? Because I'm no any other person that what maths doctor. So let's proceed step by step. Is that okay? A step by step, so that you'll be able to get the answer and you will now smile just like the way I'm doing right now. So let's proceed. The LCM is 2. 2 divided by 1 is 2. 2 times 2n is 4n. 2 divided by 2 is 1. 1 times 1 is 1. 2 divided by 2 is 1. 1 times 1 is 1. And 2 divided by 2 is 1. 1 times n will give us n. All over 3. You make this over 1 also. When you take the LCM, LCM is 2. 2 divided by 1 is 2. 2 times 1, 2. 2 divided by 2 is 1. 1 times n, n. All raised to power what? 1 over n. Okay? You see what will happen. We are moving. 3 raised to power 4n plus n will give us 5n. 1 plus 1 will give us 2. All over 2. And at this point, instead of writing it as all over fraction, I introduce this sign. So the denominator is this: 2 minus n all over 2, all raised to power what? 1 over n. Now the base are equal again. What do? We are going to take the LCM. We are going to pick, the base are equal. We are going to pick one of the base. Is that taken? We are going to pick one of the base, and that gives us what? 3. The sign here is division. What are we going to do? We are going to do what? We are going to subtract the powers. So that gives us 5n plus 2 all over 2 minus 2 minus n all over 2. Bracket close, raised to power what? 1 over n. Okay, just watch. We take the LCM here. LCM is 2. 2 divided by 2 is 1. 1 times 5n plus 2 will give us 5n plus 2. Okay, we give us 5n plus 2. 2 divided by 2, 1. 1 times this, is that taken? We give us what? We give us minus 2 minus n. Minus 2 minus n. You put it in bracket. Yes, because if you don't put it in bracket, the minus sign is going with only 2. It will not have it will not be able to change this or affect this, and meanwhile we need to. So that gives us 3 raised to power 5n plus 2 minus times 2 minus 2 and minus times minus plus n all over 2 into bracket raised to power 1 over n. That will give us 3. 5n plus n is 6n. Okay, is 6n. Plus 2 minus 2 gives 0. So we have just 6n over 2 raised to power 1 over n. The power inside multiply the power outside. Is that taken? So that gives us 3 raised to power 6n over 2 times 1 over n. And we cancel out n, and similarly 2 here 1, 2 here 3. So what do we have? We have 3 raised to power 3, which will give us what? 27. And this is the same as what we have at the right hand side. So what? QED. QED. Quick, easily done. But to some students they will say it's not easy, but I tell you it's easy. Mathematics is fun. It's a game of number. Is that taken? All you just need to do is to stay tuned to my channel, and please, I want you to subscribe to my channel. Just click the notification button, so whenever I drop in a video, you will be notified, and before you know what is going on, you are there in mass. So please just click the notification button, subscribe to my channel, Mass Doctor, as I'm going to be giving you the best.